being publicly streamed.
Yes. My screen shared with everyone? Okay. Okay, good. So last हमारी discussion है, it is almost we are going to end up our topic. And in this topic, we are going to discuss about the damping effect of the oscillation. And inshallah, we will practice some of the questions along with this all. And for this purpose, what will we do? I will give you some sort of, you know, simple logical support for damping of oscillation or damped oscillation. So in case of oscillation, as I told you before, that this all oscillation what we have learned before, that was the free oscillation. Beta free oscillation was that oscillation where there was no resistive or no driving force involved, right? That was due to the momentum of natural momentum of the body. But in the damped condition, that is the oscillation in the presence of resistive forces, right? This is the oscillation in the presence of resistive forces. This is your damped oscillation. And when the oscillation is damped, we can simply say that the oscillation's amplitude or the amplitude of oscillation gradually decreases, and it reaches to zero sometimes, but not all the times. So that is what we have to learn in this all topic, the damped oscillation wala. So amplitude decreases due to energy losses against the resistive forces. Yani, you know, why an oscillating body has sort of amplitude. Amplitude represents the energy delivered by that wave, or that represents the simply that is the that is equal to the energy. So if we have, or if we are going to have some damping, it means there is nothing but our oscillation has lost the magnitude of oscillation, right? Or it has lost the energy. So energy dissipation is against the resistive forces. There are three types of dampings here I have mentioned. I tried to mention these. One of them that is called the light damping. This one is your light damping, right? Yani your oscillation is damped lightly, right? Then after some time, if I consider this blue one, that is your heavy damping, this one, right? So somehow it is heavy damping. Heavy damping means that its amplitude of oscillation decreases rapidly, right? Amplitude of oscillation, did you see amplitude of oscillation has decreased rapidly? So it is heavy damping. You got my point? It is your heavy damping. Now the last thing, which is called critical damping, this one, that is usually in the shock absorbers, right? This is your critical damping. But a critical damping means your amplitude of oscillation does not sustain for even one oscillation, right? Critical oscillation or critical damping. So in this critical damping, what do? We have these all points to consider, or these all points to mention, that yes, what type of damping we have. Now here we have that if you are saying that the object has the oscillation, you know, the damping amplitude originally or initially, its oscillation or its amplitude is x is equals to 3 centimeter, let's say, or x is equals to 3 centimeter is the amplitude at that time. Then with the passage of time, what happens? The amplitude decreases. For example, the maximum amplitude of oscillation is 3 centimeter, but after first oscillation it is 2. After two oscillations it is 1.5. After one oscillation, three oscillations it is 1 centimeter, 0.5, 0.25, etc., etc. So this will make a curve, which is basically called your envelope, damping envelope. What do we call it? This is called your damping envelope. You got my point? It is called your damping envelope. So basically, this all is actually the situation which takes place in real time. Yani, for example, if you have an oscillator and that oscillator is oscillating uh, with respect to your yeah, let's say we have a simple pendulum in our daily life, but if that simple pendulum will stop its vibration or that will stop its oscillation after some while. Na? It is not to oscillate throughout, isn't it? Ability to oscillate throughout. It will stop its motion or its oscillation will be stopped after some time. That means that gradually, that amplitude of oscillation decreases. And this is how that energy loss takes place. Here it has more energy. Here the energy between this point to this point, yani energy has been lost because this much amplitude of oscillation has been lost to overcome the resistive forces. Now here, so for every cycle, and after every cycle, the energy is gradually decreasing, and finally the energy lost to that much that your oscillator is not able to sustain its oscillation, and this is why its motion is stopped. Now here there are some important points that the maximum energy is at the x naught. Where do you have the maximum energy? That maximum energy is basically x naught. Is it? That is x naught. X naught is the maximum amplitude, and at that maximum amplitude the energy of oscillation is maximum. Why? Because as I told you, that energy of oscillation is calculated as E is equals to 1 upon 2 m omega square x naught square. So when this amplitude of oscillation is maximum, then definitely the energy of oscillation will be maximum, right? Are you getting my point? So as these are all these points, yani all these factors, 1 upon 2 m omega squared, they are constant. So that is why whatever the energy is, that energy depends upon your amplitude of oscillation square. Are you getting my point? On the square of amplitude of oscillation. So if the oscillations amplitude of oscillation decreases, then energy of oscillation also decreases. You got my point? For example, here I have just given you a simple calculations that the calculations of energy after several oscillations, let's say here I have mentioned after 3 oscillations or 4 oscillations or 5 oscillations, whatever. So what will you do? You will use this formula that E2 divided by E1 equals to 1 upon 2 m omega square x naught square after after 3 seconds or 4 seconds or 5 seconds divided by 1 upon 2 m omega square x naught of x naught square. Yani that is the stage 1 oscillation. This is the next stage oscillation, whatever is required from it. So you people can simply manage this all. How? At x naught 1 upon 2 m omega square, that all will be gone. You will be left with this equation. This is very simple equation to understand, sorry, this is the way. Okay, so this equation will help you out to calculate the energy calculations or energy of the oscillation with respect to its amplitude. So I have just rearranged this all, yani not really simplified this equation. E2 divided by E1 is equals to x2 divided by x1 whole square, right? Did you see that? Is it? So I will just plug in the values and I will find out the energy of oscillation after some, uh, you know, some points. For example, if I just give you the energy of oscillation at this point is E and the amplitude of oscillation is x naught here. After 4 oscillations, the amplitude of oscillation is now reduced to zero point 0.5 centimeter, right? Here, how much was it? Was 1, 2, 3 centimeters. What was x naught? X naught was 3 centimeters. So what will be the energy of decrease in the energy of oscillation? You will simply plug in the values. Energy after four oscillations divided by energy at the start of the oscillation, that is equal to amplitude after four oscillation divided by amplitude at the start of the oscillation, whole multiplied by, sorry, whole power 2. So that will be E4 divided by E naught. Yani, that is what I have given to you. What is this E4? E4 is, yeah, sorry, X4 is 0.5 centimeter. And what about X naught? X naught was 3 centimeter. Just solve this value and let me know what will be you get. 0.027. Yeah, this is the ratio. So if you know that what it will be the E naught, you can multiply that 0.027 times E naught. So that will give you the energy after four oscillations. You got my point? Is this clear to everyone? Okay. Now, after this all, we have another important thing to know. For change in energy, sometimes it is asked that how much energy changes take place. So, beta, for energy change taken place, delta E is equal to E1 minus E2, or the maximum energy minus the energy at the required point. So, for this purpose, what do? You simply say that 1 upon 2 m omega square x naught square at this stage minus 1 upon 2 m omega square into x2 square. That is the stage number 2 when you want to find the energy. So 1 upon 2 m omega square will be taken out common. It is 1 upon 2 m omega square is common. So now you get x1 square minus x2 square. So never say or never do that. Yani, there is a problem which usually the student make, that is a mistake which student like do in their calculation. 1 upon 2 m omega square x2 minus x1 whole square. Hanzala, is there any uh, difference between these two equations? Yes. No difference. सोच के बताना बेटा. हाँ हाँ. जोया तुम बताओ बेटे. डिफरेंट है. हमजा आप बताओ. Are they different or same? They're different. देखो x1 square minus x2 square is different than x1 minus x2 whole square. Okay, मैं थोड़ा और भी adjust कर लेता हूँ so that you people can manage this. Let's say we can say अगर आपको ये ऐसे भी दे दिया जाए ना x1 minus x2, again they are different. Why? This is not allowed. Cut it. ये allowed नहीं है. ठीक है. That is why, यानी इसको मैं ऐसे कट लगा देता हूँ so that you will be able to understand. 1 upon 2 m omega square x minus x naught whole square is not equal to energy change beta. Because just see the mathematical aspect of this. Here it is x1 square, here it is x2 square. So 1 upon 2 m omega square will be taken out common. So पीछे क्या रह जाएगा? What will you left with? x1 square minus x2 square. Yes. Yeah, Huda, you are right. A square minus B square is not equal to A minus B whole square. अंजला बात समझ आई बेटा? A square minus B square is not equal to A minus B whole square. Did you remember this formula from maths? Yes. ठीक है? क्लियर है ये सबको? Okay. Now, moving to the forced oscillation. But forced oscillations are those oscillations. I will solve some of the questions for you just after winding up this topic because now it is about to end. So we will be able to solve some of the questions during the class. But a forced oscillation is basically that oscillation in which a driving force is present. So the oscillation in the presence of a driving force is called your forced oscillation. With the help of driving force, the amplitude of oscillation increases. And when you increase the amplitude of oscillation at a certain time, the amplitude of oscillation becomes maximum, and that is called your resonance. Right? So you people will be asked what is resonance when the frequency of driving force becomes equal to the actual natural frequency of the oscillator, the amplitude of oscillation becomes maximum. That is called your resonance, right? So you have these 2 points, which are basically for you. That what is the force oscillation? That force oscillation is the oscillation in the presence of that is in the presence of resistive force. Okay. Oh, sorry, driving force. Resisting and driving force, these are two different points. So that is why that force will be used to either increase the amplitude of oscillation or it will be used to basically yeah, it will be either used to maintain the amplitude of oscillation. And its best example is when when you are in the park and you are just you are seeing a parent or a mother providing swing to her kids. So what does she do? She just apply that much force which is able to maintain the same amplitude of oscillation, isn't it? Did you ever see that? Yes. So that is just the force which is required to maintain the oscillation. But at the same time, if the mother will apply more force, that force will become such a great that it would increase the it will increase the oscillation amplitude of oscillation, and the swing will have more and more and more oscillation. So due to that, at a certain level, what will happen? The amplitude of oscillation will increase to a maximum level. That is called your resonance. Okay. So resonance is when the frequency of driving force becomes equal to the frequency. I will explain it a little more. Just give me a second. I'm moving to a page where I'm going to apply that concept here to you. Okay. Yeah. Oh, sorry. It is just a second. Sorry. It is now. It should be here. Here. Okay. Now, for example, if you have a swing and on that swing your amplitude of oscillation increases. This is a swing, this is a simple pendulum, and for that simple pendulum that is attached with the string, okay, here, and that simple pendulum is attached, yani that is supported in such a way that its frequency of oscillation is a certain frequency. Yani it has this position, one extreme, okay, and the other position this way. Okay, let's say this is another snapshot this way. Okay, these are different snapshots what I have provided to you from one side, right? On the same way, we can say that okay, these are the same swing, these are the same swing definitely on the other side of the oscillation. So beta, that is why, what do you think that this swing is to be oscillated in such a way that it is its equilibrium position, this one, and it is returning back from this position. So this is its maximum amplitude on one side, and this is its maximum amplitude on the other side, isn't it? Do you people agree? This way. Now, what will happen? What do you think? If I am going to push that swing or that simple pendulum in such a way that it completes its oscillation. Oh my god, that has been changed. This is its one oscillation, right? This way and this way. Now, let's say that completes in 5 seconds. Are you getting my point? The time to start the oscillation from this point and returning back to this point is how much? 5 hours. It means this is actually what? This is the time period. You got my point? Am I right? Are you getting my point? So what is the time period of this? 5 seconds. Okay, so what will be its frequency? 1/5 means 0.2 hertz. Is it? Isn't it? So if I'm applying a driving force in such a way that I am pushing it, one push one or pulse one is provided it at t is equals to 0, and pulse 2 or second pulse is provided to it after 5 seconds, third pulse is provided to it after 10 seconds. So what do you think? Isn't it the same as its natural frequency? Or am I oscillating it at the same frequency as its natural or not? What is the frequency of my driving force then? 1/5. So that is equals to 0.2 hertz. So that means that the frequency of oscillation, this was your frequency of oscillation, which is called the natural frequency. Becomes equal to the frequency of driving force. That is why this pendulum or this simple pendulum will get resonance. Otherwise, no. Okay, that is why it will get it will have resonance. So it a resonance has its own frequency. At this time, at this time, yani at the time of resonance, the frequency of oscillator is called resonance frequency. Okay, the frequency of oscillator is called resonance frequency. You got my point? So this is how we consider it. Now, this is applicable in different areas. For example, in your tuning circuits, in your tuning circuits. What are the tuning circuits basically? Those circuits which are used for radio tuning, uh, uh, TV tuning, right? Radio, television, anyhow, right? Then there are several advantages of resonance, several disadvantages of resonance. But overall, if you are listening a radio transmitter, right? And you have different frequencies. Let's say it is 89 FM 89. Then this is FM 100. This is let's say FM 101. 101. This is let's say FM 102. This is let's say 104.7 and so on. So, beta, did you ever observe this thing that when at a certain tuning point, your amplitude of oscillation is maximum for FM 109. For rest, all it is zero. There is no other frequency you are receiving now. Are you getting my point? But when you tune your radio at FM 99, sorry, FM 100, you do not get anything else but only the voice of FM 100. In the same way, if you have tuned that at FM 103, you will get only this peak. Same goes to all these peaks. So basically, the amplitude of oscillation is maximum and on all these areas. So if you have this experience, you people can observe that the frequency of oscillation, when the frequency of your transmitter becomes equal to the natural frequency of that wave at which the transmission is being done, let's say 102, at that time the amplitude of oscillation of FM 102 megahertz sound, that sound which is carried over FM 102 megahertz, or 102 megahertz frequency, that would become maximum. Otherwise, that all will be less. So that is why, beta, you people have a graph in your course, that is that the condition of resonance, the driving force must be equal to the natural frequency or resonance frequency, right? Now, here is that concept that at the resonance frequency or natural frequency, the amplitude of oscillation becomes maximum. This is the frequency 0.7 f. This is the past paper questions reference value. There is a question in it. It is given that the value frequency of oscillation has been changed from 0.7 f. It is 0.7 f. It is not 0.7. 0.7 f, yani 70% of frequency to 130% frequency. At exactly at f, yani natural frequency, the amplitude of oscillation will become maximum. Otherwise, it would be less. So this is a 3 marks question. You have to draw this curve. This is called a resonance curve. What do we call it? This is called your resonance curve. Okay, this is called your resonance curve. So are you people agreed with that? Now, when the damping takes place, in case of damping, this resonance curve will be having a sort of uh, decrease in the amplitude and flattening the curve, flattening the peak. This happens. So this green one is basically damping effect. Okay, what is that? It is your damping effect. So when you have the damping effect, the curve will become lower, it becomes flat. So this is also asked to you in your exam. So here I have drawn it, but because that was just a little bit cut, that is why I just draw a new curve for you. Okay, is this clear? So these are the properties that during damping, what happens? The curve becomes flat and below the original curve. Is this clear to everyone? Any question, anything you want to ask me? Yep. Anything you want to ask me? Okay. Okay. See you then. Inshallah, I will send you the worksheet. So I hope that you people will practice the worksheet. And by that, you will be done by this topic, inshallah. This is an independent topic. There are no more, no complicated situations. There is only one complicated question. I will try my best to solve it for you and I will upload it for you in video. Okay, so inshallah I will try by Monday we will start a new chapter. Okay, see you then. Allah Hafiz. Allah Hafiz beta.